Today's problems, they are often on the SATs and ACTs and things like that. The way they'll ask you is not the way you see it right here, but the way they'll ask you is they'll say something like, what if the side lengths of a solid were doubled? That's what scale factor 1 to 2 means. So they'll say something like, what if the side length is doubled? What will that do to its surface area and volume? A lot of knee-jerk reactions is you just want to say, well, they're doubled too. But if you plug in numbers for them, you'll find out that they are not. For example, they didn't give the actual solid in this, but this is just for a quick example. So the surface area did more than double. If you divide these, what you actually get is you get times by 4. And the volume did a lot more than double as well. If you divide these two, you actually find out that it's times 8, which if you keep in mind, usually what we do is we square these. So that's where the times 4 is coming from for surface area. And for volume, we cube them. And 2 cubed is 8, and that's where this is coming from with the volume. So you have to be careful because in the word problems, a lot of times they don't give you numbers. They just say, hey, your side length's quadrupled or your side length's doubled. What does it do to the area and volume? So you kind of have to use the ratios from the scale factor to figure that out. Okay, so I've got a couple examples for us. I've got a bunch of examples because at first it's going to be a little confusing, but I think over a bunch of examples, it's going to make a lot of sense. So it says, what is effect will occur on the volume if the radius is increased by a factor of 5? When they say factor, factor means multiply. So you're not adding it. This is a factor of 5. So what we're going to do is we're going to increase by a factor of 5. We're going to increase the radius. I couldn't find what it was. So we're increasing the radius by a factor of 5. So I'm going to show you the numbers to start with so you can see where this is coming from. Some people need to have numbers to work things out to see what's going on. So I'm going to show you both ways. I'm going to show you the numbers, and I'm also going to show you a shortcut for them. Okay, so if I'm looking for volume, if I do volume, it's pi r squared h. Okay, so basically what's happening is I could do pi times 15 squared times 48. Okay, I did the numbers on the side to save time. If I did it in terms of pi, that's going to give me about 10,800 pi. And then if I increase by a factor of 5, that means what they're telling me to do is times it by 5. Okay, so that's going to give me 75 as my radius. So if I do pi 75 squared times 48, that's going to give me 270,000 pi. So if I divide those two things, what I actually get is 25. So your final answer for this, if you did it out and you actually did the numbers, is 25 times. Okay, that's the long way to do it, which you do not have to do this. The shortcut with it is to figure out what would happen if you plugged that factor of 5 inside of your formula. So if you plugged it in, it would go in with the radius because I'm doing the radius by a factor of 5. So it would look like this. You would do 5 times the radius. So what happens here is if it's in parentheses like that, you'll be squaring the 5. So really the difference between this formula and this formula is we're timesing it by 25 in there. So if this sometimes is a really difficult thing for people to grasp. If you can get this, then you can go zip right through the problem. If that doesn't make sense to you, I'd suggest just doing the problem out the long way, taking a little bit of extra time, and then dividing to see what you get. So it is up to you. I will probably show both ways, not for every problem, but I'll give the idea since I did the numbers out anyway. Okay, so next, it's the same exact thing, except this time it's the same exact picture as the first one, except I'm going to increase the height by a factor of 5. So I have my same formula. I've got my pi r squared h. This is going to be different. Last time it was times by 25. This one's going to be different. So if you do the numbers out, we already did the first one. The first pi r squared h gave me the 10,800 pi. Then if we increase the height by a factor of 5, So 240 is my new height. So now I've got pi r squared h. And if you multiply those out, you're going to get 54,000 pi. So if you divide those to see what the increase would be, if you divide them, you're just going to end up with 5. So your final answer is really, it's just times by 5. The reason, if you wanted to do it the shortcut way, if I'm just doing the height, the only thing affected is my height. So if you kind of, any numbers that you plug in there, it's just going to be times by 5. This is all multiplication. So either way that you figure out as times by 5 is up to you. This is a lot harder to understand, but if you understand it, go with it. Okay, next. So I got the volume of a cylinder, same formula that we used. Oh, there it is right there. So it says if H is doubled, then the volume is. So if you do that shortcut, if my height is doubled, then the volume is going to be doubled because it's everything times 2. Now, this one doesn't give numbers. So if you can't do it this shortcut way, you can just pick numbers. In other words, if it doesn't give you anything, and I would suggest doing this a lot, because this would be what I would do, is I would just pick any radius. I'm just going to pick a 5. Pick my height as maybe 10. I think that's what I picked. Oh, I picked 3 and 10, but whatever. So if you, whatever numbers you pick, you just assign it. So this is my original. So I would have pi r squared h, and that would give me my original. I'm going to do it in terms of pi, so I don't have to think. So this is going to be 250 pi. And then if I do what it tells me, the height is doubled. So I'm going to double my height and make it 20. This is 25 times 20. So if I do 25 times 20, that's going to give me 500. And again, if I divide, in this case, it's going to be a half because I did the smaller one on top. So that's the only difference there. So just when you would divide this, you would end up with a half, but you can think of it as 2/1. So put the bigger one, the newer one on top, I suppose. But either way, you're going to see that it's going to be doubled. Okay, so the next one would occur on the volume if the height increases by a factor of 2. So now I've got a different figure. So this is 1/3 capital BH. And keep in mind that the capital B is the area of your base. So that's for a pyramid. Okay, so if I'm trying to do this, it increases by a factor. Remember, factor means multiply. Factor of 2. So if I do that, I'm going to end up doing 1/3 times capital B. So capital B is 24 times 12. I'm just going to write the numbers in there. And then times by H, which my H in this case, my height is the 16. So if you multiply those, you're going to get 1536. And if I increase the height by a factor of 2, that means I'm going to times this by 2. So I've still got the same capital B, except now I'm going to use 32. So if I multiply those, I get 3072. Okay, so the difference between these two, again, if you divide it, like I was saying before, if I divide it, it's going to give me half. But if you do the big one divided by the small one, it's going to tell you how many times it is. So always do the big one divided by the small one to see how many times bigger the big one is. So if I divide 3072 by 1536, you're going to end up with 2. Okay, now if I did it the shortcut way, we're talking about just the height right there. So the only thing that happens if I kind of multiply the whole thing out, the only thing that's going to be affected is it's times by 2. So either way, that's all you got to do. All right, this one doesn't even give us a picture. So I know it's a cube. That means my length, width, and height are the same. It says one of the edges, if the edge of a cube is now 4 times greater, how many times greater will the volume be? So this, I like to use the BH. If you were one that liked to use the actual cube, it's just length times width times height, which is the same thing because the area of the base is length times width. Whichever one you like to use, it doesn't really matter. Okay, so if you did the shortcut way, we're just the edge of a cube is now 4 times greater, so I'm just throwing a 4 in there. It doesn't matter whether you pick the length, width, or height because they're all the same. So if I did it like that, I can just say, well, I'll pick the height. So all that's going to do is make it 4 times greater. Okay, if you do it the long way and I have no idea what my cube is, I can make it a 5 by 5. This is the regular volume. If one of those sides is 4 times greater, that means I got to times one of them by 4. That's going to give me 200. So if I've got, I'm sorry, that's not right. So 5 times 5 times 20 is 500. Sorry, wrong. So I just want to compare these. Again, you can just do the top number divided by the bottom number. If you do 500 divided by 125, that's going to give you 4. Okay, so you always want to do the new picture on top because it's going to be a bigger number on top to get a regular number. Either way works. Okay, the next one. It's another one, but this time we're talking, this one actually makes you think outside the box. So what will have a larger effect, whether you increase the height by 2 or the entire base by 2. The y is going to be the part where even when you throw numbers in, you still have to kind of understand it. So if I'm talking surface area, that is 1/2 lateral base, or lateral height, times your perimeter plus the area of the base. So we want to see which one's going to matter. Again, if you're one that needs to throw in the numbers, you can throw in the numbers and figure out what it is. If you do that, if you throw those numbers in there, you're going to have to find the lateral base. So this is 24, which makes this 12. You have to do a squared and b squared equals c squared. So if you do that, if you go through all of that and have to use the numbers, then you're going to have to find the lateral base and figure out what that is. Then what you'd have to do is you'd have to increase the height by 2, so you'd have 18, and then you'd have to find a new lateral base. 12 squared, 18 squared equals x squared. And then the last thing is you would increase the entire base by 2. So if you increase the entire base by 2, you have to add. Increasing is adding. That's why we're not multiplying this time. So it's a lot of work to do it the other way. Now, if I'm just going to do it this way, if I'm going to do the, if I'm just going to increase, and I'll give you the numbers. I wrote the numbers for you. So the original surface area was 1,008. If you added 2 to the height, it was 1066.799. And if you just added 2 to one of your bases, which it doesn't matter if you did the 24 or the 12, it's going to give me 1164. Okay, so if you wanted to figure out which one was bigger and you actually use the number, then adding the base is bigger. So you could figure that out the long way. So increasing the height or increasing the base is what they asked for. It would be increasing the base. The y is the question that you can't really explain with just the numbers. I guess explaining with the numbers would work, but a higher level math class is going to want you to use the formula. So if you did that, first of all, if I increase the height does not, the height is going to affect the capital B. So if you increase the height, that's going to affect your lateral area a little bit, but it's really not going to affect your capital B. So if you notice that, it's not going to affect the area of the base. So it would affect this up here by adding 2. But if you deal with the base, so if you increase one of the bases by 2, that's going to affect your perimeter and it's going to affect your base. So it's going to affect both of these terms because of the base. If you're just talking the height is only going to affect this term. I know that's a little confusing, but that's what's going on. So it increases both terms is what I would say. Whereas the height only increases the first term. So the y takes you a little bit further and a little bit more difficult into it. Okay, next, the rectangular prisms. So again, if you want to use the, I like to use the capital BH. For my volume. So rectangular prisms, We actually have to for this one. It's not a cube. So the edge of a prism B is 6 times that of A. How many times is the volume? Okay, so if we're talking the edge, one of the edges is 6 times, so just one of those needs to be times 6. So it's all multiplication anyway. So it doesn't matter where you put your 6, whether you put it in front of the B, whether you put it in front of the H, it's all times 6. So this is just going to be times 6 times. Okay, and then one more normal one, and then I'm going to give you a little bit of a challenge at the end for some of you that like a challenge. All right, so it says the diameter of a circle is quadrupled. That means times by 4. Then the area of the new circle will be how many times greater? So area of the circle is pi r squared. So if you're doing it the shortcut way with the formula, the diameter is quadrupled. Again, use numbers if you get a little confused. So let's say the diameter is 10. If you quadruple it, it's 40 because we've got radius over here. So we got to figure out what that does to the radius. So if my diameter is 10, my radius is 5. If my diameter is 40, my radius is 20. So it's still times by 4. Whether you quadruple the diameter, it's also going to quadruple your radius. So shortcut way, we quadrupled my radius. So it's not going to quadruple the area. It's going to, I've got to do 4 squared. So it's going to be times by 16. Again, if that doesn't make sense, use your numbers over here. So if I've got pi r squared, that's 25 pi. And if I've got the 20, that's going to give me 400 pi. So if you divide 400 pi divided by 25 pi, that's going to end up giving you 16. So if you have trouble understanding this, assign the diameter numbers. Just assign anything you want. I wouldn't pick something like a 2. A 2 is a bad idea because 2s and 4s and that kind of stuff. So anything but 2s, just assign them numbers and it'll work out. Okay, finally, your last one. So we've got how much larger will the surface area and volume for the figure be if the height is increased by 4? I didn't write down that formula. Okay, there it is. Okay, so we'll do the volume first because the volume's the easy part, and then I'll give you the challenge. So the volume is capital BH. So if I increase it by a factor, this is factor, this is multiplication. So factor of 3. So I'm going to times the height by 3. So if you're a numbers person and you want to do capital B, since the cube, everything's 7. So you've got 7 times 7 for your capital B, and then I've got 21 as my height. If I did the original, it's just 7 times 7 times 7. Okay, and if you multiply all those together, that's going to give you 343. And then the new volume, if you times those together, you're going to get 1029. So if you divide 1029 by 343, you're just going to end up with 3. So the volume is 3 times. Okay, now the surface area. Surface area for my folks that like a challenge. Because the issue with the surface area is it's really hard to explain with the formulas. So I would like you to figure out how to explain it using the formulas. I can do it using the numbers. So if I end up doing the numbers, I've got surface area is HP, so height perimeter, plus 2 capital B. So if I do the original, my height is 7. My perimeter is 7, 7, 7, and 7, which is 28. And my capital B is the area of the base, so 7 times 7, which is 49. So my original surface area is 294. Now, if I do this and I times it by a factor of 3 for the height, that means I'm going to end up with 21. And then this is still going to be 28. And then this is still going to be 49. So if I times that, you get 686. Now, if you divide those, you're actually going to end up with 7/3. So the surface area, I can give you the answer to this. The surface area is 7/3 times. The thing I can't give you, and the thing that I would like you to do for maybe some extra credit, which you kind of just have to shoot me an email and do your best to explain it, is why that works in your formula. So I even asked another math teacher too, so it'll definitely be a good bonus if you can figure out how to throw in the times 3 into this formula to get 7/3 times. Also, if you wanted to use the other formula, which we were trying the other formula as well for a cube, because you get 2 width height, 2 length height, and 2 length width. You can use this formula as well for the cube, keeping in mind that the height, so the height would be the 1 times 2. Yes, I know that the length and the width would be the same, so you can use the same letter there if that helps you. But yeah, 3 of us were sitting together trying to figure out a way to say why it works in these formulas. And I came up a little short. So extra credit, figure out why the 7/3 would work in the formula, whether it's this one or the red one, whichever one works for you. So that's extra. I put it at the end of the notes because otherwise I know you guys would be trying to figure it out. But make sure you do your homework first and then maybe work on the challenge. Okay, good luck.